Good morning, Geometry Honor students. So Mr. Chen again. So today I would like to talk about one of the extension sections for Unit 11. So this one is not even mentioning from the textbook there. It's not section 11.7 because that comes from the different textbook. So this one is just extension of Unit 11. So if you guys using the enjoyments of art of problem solving or geometry enjoyment of problem challenge for geometry, you'll see that it's part of the section right there. So normally that's the textbook we use for geometry honors. So the objective for the lesson today, find ratios of area by calculating and comparing the area. And number two, find ratios of area by applying properties of similar figure. Okay, so as you can see that objective, so one is talking about the two different type of triangle, finding the ratios of the area, and the other one is finding the ratios of the area if those figures are considered similar. So find the areas of the figure shown and find the ratios of areas. So as you can see that this two triangle, they're not similar, okay, because that they do have different side lengths right here, and also it's like a different ratio set. So 6 over 8, it's considered, if we divide it by 2, then that would be 3 over 4. And then the other one, 12 over 10, the ratio, then that would be completely different. So they're not considered similar triangle. So what we can do here, find the area of the small triangle first. So then that would be considered 1/2 times the base times the height. So 1/2 times 12 times 6, so 6 times 6, which is 36. And then the other one, the area of the larger triangle, so 1/2 times the base times 10 times 8. So we got 5 times 8, which is 40. So comparing the ratios of the area, so set up that the number, so the smaller number goes on the top. So 36 over 40, bigger number goes down the bottom. Reduce it, divided by 4 top and bottom, so we got 9 over 10. So the ratios of the areas of these two triangles, so then that'd be 9 over 10. So again, if the figures are not considered similar, so you need to find out the area first before you compare the area to set up the ratio. So now, what about the triangles or the figures that are considered similar? So a pair of corresponding sides of two similar triangle are A and 10. Okay, so two similar triangle. So the side length would be what? One is 8, the other one is 10. So they're similar. So similar, we talked about that already, similarity. So that means can be proved by what? Angle, angle. And also can be proved by side, angle, side with the proportionality. Or could be proved by side, side, side with all those three sides proportionality. Okay, so instead of finding the area of the triangle here, there's no way we can find the area because that's only given with one side length. So we can always use the shortcut. So set up that the ratios of the side, the segments, so A over 10. So reduce it. So we do have 4 over 5. And then once we come up with that, the ratios of the segment, we can always square that, the ratios of the segment, because the area will be considered two-dimensional. Okay, so the ratio that we have for the perimeter, it's 4 over 5, because that's one-dimensional, but the area is two-dimensional, so we have to square the number, top and the bottom. So eventually, we will get 16 over 25. And that would be the ratios of the triangle's areas. And then the other one, it's quite similar. So find the ratios area of the regular hexagon. So anytime they see the hexagon with the smaller segment, the bigger segment, it doesn't really matter because they're all considered similar, because that all those angles, if you divide it, come up with that, the sum of the measure of all the angle, it's always n minus 2 times 180. So which is what? It's 6 minus 2 times 180. So 4 times 180. And then which is 720. So the measure of all the interior angle, it's always 720. So 4 times 8, 32. 1 times 4, 4, plus 3, 7. So 720 degrees. So that means this two hexagon got to be similar. So again, the way to find out the ratio, so this one is the comparison of that, the bigger hexagon to the smaller hexagon. So 12 over 4. And then whatever the ratio that you have, you want to square that number. So 12 over 4, which is 3 over 1. And then you squared it, so then that'd be 9 over 1. So the areas, the ratios of areas of those regular hexagon would be 9 to 1. Okay, so now let's see what else that we have for this. Find the ratios of the area of two equilateral triangle. So this one is showing that equilateral triangle again. So three sides got to be equal. Again, if all those three sides are equal, one is smaller, the other one is bigger, it doesn't matter. They're always considered similar because that proportionality theorem, it shows that the triangles are similar by side, side, side. So comparing the segments, so this one is 8, this one is 10, so a over 10, and then quantity square. So we got 4 over 5 quantity square. So then that'd be 16 over 25. So the ratios of areas, then that'd be 16 to 25. And then the other one is quite similar. Well, this one you can find the area as well, but the thing is, we talk about the similar right triangle. If just divide this one into three different part of triangle, we do have small, medium, and large. And they're all considered similar right triangle. Okay, so you just redraw the triangle here, the small one, which is what, CDA. And then the medium one, if you just rotate this one clockwise by 90 degrees, you'll get BDC. And then the large triangle, which is this whole thing here, then that would be considered BCA. Okay, so one thing that we noticed, so CD is 5, so CD is 5, BD is what, 10, so BD, okay, so BD is 10 right there. So this one is just the medium triangle. In order to find out this segment, you can do that. So using the proportionality. Again, it's all about the comparison of the base of the small triangle and the medium triangle. Okay, so this one for the small triangle, so CD, it's given as well. Okay, so this one CD, which is 5. So again, the height. So comparing the height, so we do have 5 over 10. And then once you squared it, so we do have 1 over 2 quantity squared. So the ratio of the area, then that will be considered 1 over 4. So 1 to 4. So triangle ACD versus triangle BCD, the small triangle, compared with the medium triangle. So the area's ratio, then that will be 1 to 4. Okay, so that's it for this part of the lesson. Again, this one is the extension of Unit 11. So this one is not even mentioning from the textbook there, from the big idea, but it's coming from the other one. It's called the Enjoyment of Problem Solving for the Geometry Honors class. Okay, so I'll see you guys next time.